Assalamualaikum and good evening, Dr. Hamid. We from Group 2 will present Project 1, which focuses on surface roughness and rechecking in relation to project created by Cohort 1. There are 3 people in our group, including me, Muhammad Khwarizmi, and my friend is Muhammad Muizuddin and Watson FP. So we were told to reanalyze the project that Cohort 1 had complete based on this project 1. We must located the issue arose prior to, during, and following the project execution. We were asked to make measurement and surface roughness data public. We will double check all project results to see if the actual measurement match the reported measurement or not. Surface roughness is the measurement of the relative smoothness of a surface profile, calculated via the microscopic deviation in a surface true form. The larger the deviation from its true form, the rougher the surface, which the smaller deviation, the smoother the surface. In CNC machining, the surface roughness will influences how the manufacturing part will interact with the surrounding environment. A typical CNC machining finish as machined is smooth to the touch, but will contain visible machining lines from the cutting tool. This level of roughness is suitable for most parts. However, in some instances, a smoother surface is required. A smoother finish can be desirable when designing sliding part, as it will reduce the friction between parts and increase oil performance. An additional slower machining step or a post-process finishing step such as polishing to achieve machining step, or a post-process finishing step such as polishing to achieve a smoother finish. Manufacturing costs increase as roughness reduce, so there can be a trade-off between surface roughness and cost for some parts. There can be a trade-off. Sometimes it can also be desirable to have a rougher surface finish on a part. For example, a seat post on a bicycle need to have a high friction coefficient not to slip down when used. A roughness finish cannot be achieved through machining. A secondary process like bead blasting or tumbling is required. There is no one way to achieve a particular surface roughness, as both the machining process and secondary finishing influences the surface roughness.
Okay, for my part is equipment tech and technology. Here we use type cutting tool and measuring tool, machine and software. Number 1 is admin with diameter 16 mm and 5 mm to level the surface of the workpiece and make a profile. Number 2 is ball mill with diameter 6 mm to remove sharp corner. Number 3 is center with diameter 3 mm to make a center hole on the workpiece. Number 4 is twins drill with diameter 8 mm and 10 mm to make a hole in the workpiece. Number 5 is 3-axis milling Honshion machine to produce product molding gear. And number 6 is CATIA V5 software to draft injection molding part. Number 7 is vernier caliper to measure the product. Number 8 is software roughness tester model LEEB 452 to determine the surface texture or surface roughness of a product.
Okay, next part is result to check the male gear part. In the world of machining, we must be careful and watchful in doing a job. For example, when we get a project from another department, we must remeasure and check whether it is according to the spec that has been set in drawing or not. The process, this is also able to detect the defect that have gone wrong, and the operator who runs the damage can be blamed. In the drawing, the dimension has been specified and also have tolerance that need to be followed. As in this slide, I will check the length of the entire mold and the height of the entire mold of the male gear part, which is dimension before is 90 millimeter and dimension after is 98.60 millimeter. For the second picture, the dimension before is 25 millimeter and the dimension after is 24.52 millimeter. The tolerance for this project is plus minus 0.5 mm. Next slide is for the third measurement is the round diameter above the male gear part, which is 45 millimeter before and after 44.72 millimeter. Then the fourth measurement is the diameter of the round based on drawing is 5 millimeter and after machining it's get 4.90 millimeter. Next slide is for the fifth measurement. We measure the pinhole for the mold, which based on the drawing is 10 millimeter in diameter. After finishing the machining process, we get a 10.5 millimeter hole. And then next, the sixth measurement in the thickness measurement on the base of the mold, which has dimension of 20 millimeter, and after the machining process we got 19.60 mm. The last picture show the measurement we made to measure the surface roughness. The original measurement was 0.25 micron and the measurement we made we got 0.26 micron. Next slide. On the next slide, we check the dimension of the female gear part. The first picture we check is the overall length of the mold. According to the drawing is 90 millimeter and after the machining process is 89.66 millimeter. The second measurement is the length of the entire mold from the drawing is 25 millimeter and after machining it is 24.86 millimeter. Next, we check the pinhole, which has a diameter of 10 millimeter, and after machining, we get a hole of 10.02 millimeter. In the fourth picture, we check the mold profile, which has a radius of 5 millimeter, and after the machining process, we got a radius of 4.76 millimeter. Next slide, the fifth inspection of the radius of gear, which has a radius of 22.5 millimeter. After machining, we get a radius of 22.62 millimeter. Then the sixth inspection, which is the radius has 17.5 millimeter, and after machining, we get a radius of 15.63 millimeter. Next slide is the seventh inspection is 5 millimeter and the result machining is 5.1 millimeter. The seventh inspection is 5 millimeter and the result of our machining is 5.10 millimeter. We check the depth in the mold, which has a depth of 15 millimeter and the result of machining is 15.30 millimeter. Finally, we check the surface roughness of the female gear part, where the original surface roughness was 0.18 micron and the second check was 0.18 micron as well. And the summary is, analysis is a crucial tool for reaching objective, planning strategies, and making decisions. Analysis ensures the use of resource assists with data and information as identifies opportunities and risks. Product can become more adaptive, efficient, and competitive in a market that is constant changing by understanding and using analytics effectively. Okay, that's all from our group. Thank you.